We are going to start with a wonderful speaker, Russel Shields. And Russell has a really fascinating and beautiful history with respect to starting companies. He founded two companies, Shields Enterprises International, and then joined his wife's company, Egomi. And their goal has really been to foster new companies and new ideas. The one that comes to my mind with most strength is Navtech. So I don't know how many of you know Navtech. That's the map database company. So when you're driving around in your car, there's a reasonable chance that you're following Russell's directions. I'm not sure if he's taking emails in case there are any faults in that, but I doubt it. And there are two particularly cool things I'd like you to know about Russell. One is he's a member of the National Space-Based PNT Advisory Board, which is a presidential advisory committee, and I know that Brad certainly and the whole board counts on Russell for his help through that. And the other cool thing is that he's the first U.S. member of the Intelligent Transportation System Hall of Fame. So I thought that's a good indicator of what he's about. Please help me in joining Russel Shields.
Thanks, Per. What that mostly says is that I've just been around too long in doing some of these things, and it's been pleased to be invited here because I'm a software guy. I don't know anything about this stuff that was talked about this morning. All great and interesting, but yeah, we use that. We don't do it. By the nature of software means that we've been involved in a lot of things. And fortunately, smart guys, one of you heard Marty Cooper, who introduced me to communications in 1979, and worked with him on a couple of our companies, has led to things including being the head at the ITU. For those of you who know much of communications is the UN part of this, leading to some really interesting stuff. So, smart vehicles, you get a lot of talk. Don't believe most of it. We're going to do it. It inevitably happens. And the nice thing about software is we just wait until the communications costs get cheaper and better and the chips get better, and then our stuff works. Pretty easy, really. So the telematics and navigation have been around for a while. You do have the systems that can have a crash and it will call 911 here. Most of you have used navigation and mapping. Nothing particularly unique about that, except when I grew up, my maps were Rand McNally and AAA, and I doubt if even the younger people in here have recently used a actual paper map. So I had to throw in augmented reality just because I think it's a very critical piece of what's happening. We've had heads-up displays for a long time. You'll get a copy of my presentation. I put in a few references. But we're trying to help the driver understand what's going on so that once he understands it, then we can replace him by having an automated capability. But the automated capability is a long ways away. And we really have to avoid overdoing it because a lot of the systems that have come out, I think, have actually made more distraction than they saved. But that's the nature of technology. You try it, you fix it, you try it, you fix it. And in the 10th or 20th iteration, maybe we make it work pretty well. Vehicle-to-vehicle communications, I had to put this in for my dear friend Karen back there, as you can tell her colleagues. we've started doing vehicle type of communications, got the FCC authorization in 1999, besides Japan, who tends to do different communications all the time, most of the rest of the world's using 5.9 gigahertz. Well, when we started this stuff, the only standard in 1999 that was OFDM TDD was 802.11a. So we said, okay, we'll go use that as a test bearer protocol. Now you got research guys who spent 15 years working on this. And even though the rest of the world is moving forward because LTE finally woke up, and now normal wireless communications has TDD in it, and now normal wireless communications has direct, and we can actually do vehicle-to-vehicle communications. Our government is about to mandate using a 17-year-old technology. Normal. 15 years from now, we'll probably get it fixed. But in doing the vehicle-to-vehicle communications, what they're putting out is only warnings because they don't have any idea how to actually do it right. And my bet is that most of you, when you get a warning 5 times a day that says a car's coming to the intersection, will turn it off pretty soon. For it to really be useful, we have to actually be able to control the vehicles. Now, how do you control the vehicles and make them not hit each other? You got to be really, 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 really sure that you've got the right information. And unfortunately, and I see my dear friend Logan back there, who's an expert in this, in our great wisdom of how we run our country and these things, we don't seem to be able to keep the GPS jammers out of cars. And there's a lot of them. And until this problem gets fixed, and I don't know how it gets fixed because you can buy the stupid things on the internet, and so far FCC and the Customs Department is not very good at stopping it, pulling them, what have you. We just don't know how to do it. So it's a tough problem. We really need it, but we just have not a clue. And different from other things, this will kill people. We try to implement this stuff, and we get some idiot who doesn't want his boss to know he's seeing his girlfriend and sticks a privacy protection into the power cigarette lighter and knocks out GPS for half a mile. That's bad news. So when sometime maybe we'll have solutions, it's coming. So in our great wisdom, our government, NHTSA as we call it, has now agreed with the rest of the industry on at least what we call automation. Now that's a major step. That only took 4 years. But a couple of months ago, NHTSA did come out and agree that they would accept the definitions from the Society of Automotive Engineers. So now we can at least talk in the same things. And basically, level 4 is the first one that really does anything that you would actually think was automated driving. So we've got a lot out there now in specialized things. Farming, my good friends from John Deere have done a great job in getting that. We have it out in mining. I was in Australia a few weeks ago, and they've done great in those. We're working in Border Patrol and other things. And these are working in closed environments. And in closed environments, we can protect things. You can make sure that there's no jamming. You can have enhancements to improve the reliability of the GPS signal. And if you're driving your tractor doing the combine and it comes back with a big red light that says, stop, we got a problem. Okay, you do that, and maybe it happens once every couple of years, and it's not a big deal. If you think about your cars and your probability of having a fatal accident, serious fatal accident, on any one day is minuscule. Even though big numbers, we kill, as the numbers are, 36,000 or so people every year in the U.S. It's a lot of numbers. You take out, that includes some motorcycles and bicycles and what have you, and it's about 30,000 people. So it's almost 100 a day, and it's a big number. More people were killed in vehicle accidents in September 2001 than were killed in the World Trade Center. But it happens every month, and it keeps happening. So it is big. But if you actually divide 30,000 people by a population that's getting close to 300 million, it's a small probability. And we have to do much better than that. So that's where our challenge is. So we've had a bunch of demonstrations, and a lot of the work is doing trucks. There's a belief that at least on the open road, on the expressways, we can do a better job of how we keep the freight moving. It actually has an economic potential. Allows the drivers to sleep while they're going down I-80 across Kansas. Big help. Those are coming. If you're interested, you can see some of the examples, I think. But if we talk about your car, all the hype, you read it, automated driving, automated driving, automated driving. No, it's coming bit by bit by bit. We really don't quite know how to do it all. We got ideas. We got lots of engineers working on it. My company has over 100 working on one little teeny bit of this. We're trying to figure these things out, and we've got regulatory problems, we've got legal problems, but mostly we have technology problems. We can't make mistakes. Very little experience in software has been around things that people die from mistakes. The medical industry has worked on some, but the medical industry and the medical devices are mostly in very closed environments. We're trying to work in an open environment with a lot of people around, many of whom don't do what they're supposed to. And then we throw in little accidents, and the dog jumps out of the back of the pickup truck onto the highway while you're about to pass it. We'll have to figure out how to do it. So we're trying to improve things. We've got new generations of LiDAR. ITU finally approved last November a much bigger band, 78 to 81 gigahertz wideband radar. We've been trying shortwave infrared. It sort of works, but it's hard, and we've been working on improved IMUs. We've been working on enhanced satellites, and our Japanese friends will put their advanced satellites there, and then you talk to Toyota or Nissan or what have you, and they say, well, we can't use them because even their expensive satellites don't work in the cities and under the expressways, all of which are elevated in Tokyo, and similar issues. So they're an issue. But we are working on it. GNSS, we use certainly, and we'll always use it in automated vehicles for approximate positioning, to know approximately where we are. Precise positioning, and precise positioning really means knowing at all times, at less than 10 centimeters error rate, where the car is in the road. That's something that is not easy to do. And we're doing it piece by piece. We're making major efforts to try to capture absolute detail of what the map is, only we no longer call it a map. It's really, for those of you who know engineering, it's more like a computer-aided design drawing of the empty road. Big problem, long ways to go. We're doing that, and then if we know approximately where we are, then we look at things like cameras. Cameras tend to work better than LiDAR in short range. Most of you have driven in the fog, heavy rain, or what have you. You do it by your eyes. It's not easy, but you can see 3 or 4 meters. Well, we can do that in the cameras. We're trying to figure out how to do it, but it's not easy. And will we get it out there? Yeah, sometime. How soon will it be reliable? I don't know, 5 years, 6 years, 7 years, maybe, if we're lucky. So we have serious problems with this. Unintended consequences in the car industry is really, really bad. Big issues. We got new systems that are nice that will show you things like, oh, over in your mirror, we can show you is there a car in your blind spot. And we tell you it's a warning. And we can come back 3 months later, and almost nobody actually looks back anymore to see if there's something there. And I assure you that that blind spot warning system that you're relying on is not as accurate as your eyesight. There's something there, there'll be a mistake. It happens once in a while, but it doesn't happen very often. And it's probably one time in a million that somebody changes lanes and actually hits something. We're nowhere close to that. So we're trying to control it. We have a lot of publicity about things that have been put out that are not complete and people misusing them. That's the human, and if anybody here is smart enough to know how to control the human side of this, then they will really be the winner. So we've got to update regulations. We've got to control the regulations. They got to be consistent. We struggle, as many people who work in the mobile phone, with different frequencies around the world, different things, different things. If your mobile phone doesn't work right when you get off the plane, it's annoying, but that's it. If you get in the rental car and it doesn't work the same way, and you're confused by how it works in this new fancy automated thing, that's a big problem. And how we get that consistency, working in that consistency around the world, very, very hard. And at some level, there's privacy, and there's big arguments about privacy, and some of you may know that our Europeans, especially the Germans, have been at the top of the privacy issues. Interestingly enough, in the regulatory discussions, the German transport ministry, and they brought it into the G7 transport minister meeting a couple months ago in Japan, is now taking the lead that says, in an automated vehicle, if it's running and automated, then what it's recording is public interest to know if the vehicle crashed, why it happened. And talking to some of the senior German government officials, it was a serious argument that they fortunately won within the German government to say we come down on the side that the public interest around automated vehicles to know if there's a crash and it was caused by the automated vehicle, we damn well need to know why so we can fix the software, update the software, and not keep having the same crash occur over and over again. The lawyers don't like that. Liability lawyers make their living on having cars do the same crash over and over again. That's a fight. But an even more interesting problem on this is, for example, it's certainly illegal in most environments to be texting while you're driving down the highway. Pretty good reason for that. Indications are that texting while driving is about 10 or 20 times more dangerous than drinking and driving. But if I do now really have my nice automated vehicle, and it actually can out here run a 101 and what have you, then I should be able to text, play with my internet, watch my movie or what have you. Now, how do the police authorities know that this car is actually in automated mode allowed for you to do that? Well, I was actually in Geneva a month ago, and half a day among the regulators was spent arguing about what to do about this problem, where the answer is, we don't have a clue. If we put something like a light that says this car is in automated mode, then most people know that it's going to get bluffed and played with, and people will cut in front of it and what have you. So we don't really know how to identify it. Will there be something special that the police can know? Will that require infrastructure and implementation of police cars? We don't know. It's a typical kind of problem that isn't solved. So with that, and the UN is big involvement in this, we have this great thing called the Vienna Convention. The U.S. isn't a party to the Vienna Convention, but it is a party to the Geneva Convention, which is about 15 years earlier than that, but pretty much says the same thing. And right now, the rules in the U.S., in Europe, in most countries, are that the driver should always be in control of his vehicles or his animals. Literally. That's what it says. They tried, made an effort, went through a 5-year process to update it, and they got it wrong. The update actually doesn't even allow existing things like your electronic stability control. The update says it's okay if the driver is able to take control of the vehicle as an amendment to this incomprehensible set of other things that's in there. Well, if my car kicks into stability control, I can't take control. So literally 5 years were spent in the UN process updating this thing that doesn't even cover the current systems. So there's a new effort. And another big problem. There's a bunch of meetings on it and what have you. We have others. I mentioned this one because it's pretty famous in the industry. Right now, it is illegal for the car to automatically steer at more than 10 miles an hour, or 10 kilometers an hour. Now, some of you may know that Tesla has put in their automated steering function. It's illegal. They don't care. Tesla seems to love doing things illegally. They put their great big screen in the car, doesn't follow any of the rules, and now there has been for 20 plus years agreement among all the car industry about what their driver distraction rules are. But it's an agreement, cooperative, everybody followed it. Tesla decided, well, it's not a law. So what do we have? We have our government right now working on the Tesla Memorial driver distraction regulation that will prevent what they're doing at the pain of everybody else. So it's a serious condition of things. If you go back and look at my presentation, level 2 is sort of semi-autonomous, what Tesla's doing. Level 3 is a great thing which says it will be in automated mode, but if it doesn't know what to do, it will just tell you to take over. Now think about that. I'm driving down the expressway in my nice automated mode. even if I'm paying attention. And I can put my hands in the steering wheel in 5 or 10 seconds, but the car tells me, oh, my brilliant control system doesn't know what to do. You're going to be scared. What's your situational awareness? Why is there a problem? Probably we'll skip that. We'll mostly go to level 4. And we're really looking at 2 types of level 4 systems. One is similar to what Google has been working on, that would be relatively low speed in controlled environments. Gated communities for the retired in Phoenix, maybe some university campuses that Ford's talked about, though not sure that that's going to work too well, because I think the students will go try to bluff the buses and what have you that are running in automated mode, but they're trying those kind of things. And it certainly does work in some of the other things where there is ideas. For example, Mercedes, which has car sharing, car-to-go they call it, is looking at something that would have a limited capability, that they would have a garage where the cars are and test out the major arterial roads within a mile or so of that garage. And if you wanted a car, maybe it would come on that major road to pick you up, or you can leave it on that major road and it can get back to it. Only on those major roads. And maybe they'll get that out in the next 5 years. There are efforts to do a highly automated driving level 4 on, as we would call it, limited access highways, freeways out here, expressways where I live. Maybe we'll get that out in some limited areas. We'll have a very hard time on 101, and I'm pretty sure that's not going to be one of the areas. We can do a little better in 280, where it's a little less congested and a little less cut in and out and other things. 2020, CEOs have said they're going to do it. Most of their employees think they'll slip a year or two. But we will finally start to getting on limited expressways the ability to have automated driving, if our environmental friends don't succeed in getting the next administration to prohibit it, which they've already been working on. Because what are you going to do if you have your nice automated car on the expressway, you're Joe factory worker or Jane nurse or what have you? Well, I can move 20 miles out to the expressway. What do I do when I'm at home? I play with Facebook or watch my movie or what have you. So I can get a much nicer house. And so I spend another 20 minutes or so in my car each way. I don't care. It's what I'm doing anyway. My family's happy. I saved some money. Not very good for the environment. Urban sprawl, more traffic, more use of electricity powered by not the most environmentally friendly things. These are all parts of this overall thing. So what do I think? I do think there will be level 4 on limited expressways. I think it's going to happen. I think possibly in 2020 is my sop for my customers who have to say they're going to do it then. I think they missed by a year or two, but it's not far off. 2023 is a reasonable chance where we can start having some automated capabilities for the long-haul truckers. That will be a significant benefit to people. We are working on these semi-automated capabilities where we will slowly but surely be able to get the information to know what the signal is. As we call it, signal phase and timing. It's green, it's going to change to yellow in 14 seconds. The yellow is 4 seconds, etc. That will probably roll out in most places besides the U.S. because the U.S. in our great wisdom has decided that for what we call public safety, many of you know a significant part of the upper 700 megahertz band has been allocated to public safety to use LTE. Well, as I said, the NHTSA, another part, the DOT part of our government, is at the same time going to a completely different technology to use 802.11p. So we'll be behind, but that's okay. We do it for. And we're certainly going to have a lot more of these specialized structures. So that's my summary. Thank you very much for your attention. My final message is, it's just hard. It's going to happen, but it's hard. Thank you.
Yes, I had an experience. I was in the lane, stopped at a stoplight next to a car, driverless car in the left turn lane. And it pulled out about a car length and stopped because the car making the left turn on the 100 feet on the other side pulled out straight ahead before it started making its turn. And then as it started making its turn, then the driverless car went ahead. So when you said about students feigning buses or cars, I can see that as a sport, which could be dangerous. But most of the accidents I've almost had but never had is when I'm behind somebody who pulls out and stops when they're making a turn, because I want to pull up and I'm looking to see if there's another car coming to the left.
Yeah.
So does there have to be a data link between cars like they do with airplanes for TCAS?
Well, that's why I say the vehicle to vehicle we talked about, we don't know how to do that as anything but warnings that would irritate people. We'd like to have it. We have to have no jamming in GPS and no spoofing and other things to be able to do it. But the point you're making is you have lots of these near accidents, and they happen. But, and statistics are always things that can be distorted. And Tesla will tell you that, well, their things are safer than cars. My take from knowing the accidents that happen in the statistics, that actually the Tesla Autodrive is more dangerous, killed people more often per million miles of driving than nothing. So that's where we're in this very fine line, because these conditions, and you talk about conditions, and we work about trying to figure this out and trying to figure out what the human's going to do, because humans don't follow the rules always. They do run lights, things. We have huge software problems to try to solve all those things before we can get them out into the real world. So we're going step by step, trying to make the sensors better, but mostly it's software and making the software smarter. And that's why all the tests are out here with people running around with their automated cars, trying to learn from their mistakes.
Okay, thank you.
Thank you.